So good day everyone. So I just finished doing the lab report 6, which focuses on root locus analysis. This experiment helps us understand how the closed loop poles of a control system move as the controller gain K changes, and how this affects the stability and performance of the system. On the first part, the lab introduces the basic concept of a closed loop control system. The block diagram shows the controller, plant or process, and the feedback sensor. The purpose of this setup is to make the system output follow the input by minimizing the error signal. The characteristic equation and closed loop transfer function were also introduced. From this, we learned that the roots of the characteristic equation are called closed loop poles, and these poles determine the behavior and stability of the system. So the open loop system was analyzed using pole zero plots. The report explains that the system is unstable because the open loop pole is located at the right half plane, or RHP. This is important because poles in the right half plane cause the output to grow uncontrollably. The page also explains the root locus condition where the angle of G of S times H must equal plus or minus 180 degrees. So the different values of S were evaluated and placed in table 1.0, and the corresponding values of K and the angles were calculated to determine whether the chosen points belong to the root locus. MATLAB was also used with the root locus command to generate the root locus plot. So the plot and the table are directly related because the computed closed loop poles appear on the root locus graph. The report also defines root locus as the plot of all possible closed loop poles as the gain K changes from 0 to infinity. The experiment compared the step response when K equals 4 and K equals 6. The results show that for K equals 4, the response became unstable and increased exponentially, while for K equals 6, the response became stable and flattened out. This demonstrates how changing the gain directly affects the system's stability and performance. And finally, another transfer function was analyzed using root locus and the rlocfind command in MATLAB. The report confirmed that each closed loop pole corresponds to a specific gain K value. So the conclusion emphasizes the importance of root locus in designing closed loop control systems because it allows engineers to predict stability, overshoot, settling time, and overall performance before implementing the system physically. So overall, this laboratory experiment was very helpful because it combined both theoretical and calculations and also MATLAB simulations. It improved our understanding of root locus analysis and showed how control gain affects the behavior and stability of a control system.